I'll try to keep this from being too long and drawn out and boring, but just to give an overview of our backup power system at the house. This is something I installed myself. I bought the parts and pieces and did the installation myself, so the wiring looks a little sloppy, but it's completely functional, completely safe, and completely up to code. It's just not dressed up real pretty. Simplest overview. This is a disconnect panel. It's got regular grid power coming in there. And that's your line in right here for your secondary power, whether that's generator or battery or whatever. That feeds down to a sub panel, which feeds the circuits in the storm cellar. The backup power itself on the battery side of things is powered by a bank of 8 12-volt, 200 amp hour lithium iron phosphate batteries that wire up to individual disconnects for the negative and the positive, and those are charged and controlled by a pair of grow watt 3000 watt inverters. The first inverter feeds breakers 1, 3, and 5 on the sub panel over here. The second panel feeds breakers 2, 4, and 6 on the sub panel. And the transfer switch, most people are probably familiar with the concept. Pushed over to this side as it is, it's running off of the normal grid power coming in there. If you push it over to the other side, you're coming off of secondary power from either the generator or the batteries. The reason this secondary input goes to a plug is to give you the option of using directly from the generator or the battery backup system. This line right here, that is directly in from the generator, 240 volt, 30 amp, and it comes in and travels across, goes all the way outside to a generator inlet box. So if you plug these two together, flick that guy over, you're running directly off a generator, which is how most people do generator backup. You're just running constant power. The problem is you're having to run the generator every minute of the outage, whether you're using full capacity or 5% of its capacity, you're still running the generator non-stop. The battery backup is more efficient and doesn't rely on continuous power coming in from the generator. This is the outlet box from the inverter charger panels here, which are what control the battery bank. So if you plug this guy into him, now you're running off the battery system. And the battery system will run that sub panel, the whole storm cellar / man cave for nearly a full day. The longest I've run it is about 19 and a half hours, but it was still going on, so I could definitely do over 20. So assuming you're running off of battery power here, being controlled by the inverters, and you need to recharge the batteries, you take your input from the generator, bring him back over here, and he plugs in right in here. Right now this is completely disconnected from the grid. The batteries are fully charged and it's just sitting here completely isolated. In normal use, you would have it set to line, which is grid power coming in. When you want to run off the generator to recharge the inverter battery system, you stick them up there with that guy plugged in there, and that provides power to the inverters, which are what maintain and control the batteries, and in turn feed out to here and give you power back to the room. Everything's powered down right now. I'm running off strictly grid power for the moment because I'm reaching in and grabbing all this stuff. But I'll power it up and show you how it works. And maybe that'll explain it better than I am right here. This is just papers, manuals for the inverters and different paperwork regarding the system. That's the remote start for the generator. So once everything's initiated, you don't have to run outside to start and stop the generator. You just start it, let it run for 4.5 to 6 hours to charge the batteries, and then turn it off, and you're good for another day. So let me get this powered up, and I'll show you how it works in action. Okay, so right now everything is set up the way most people would tend to leave it, as an uninterruptible power supply that doesn't even flicker if you lose incoming power. Instead of using the main power in, we're using secondary power, that guy right there. Goes through your disconnect and your transfer switch over here. You can see he's set to line, that's incoming grid power. Comes out of there and he goes to the inverter chargers. The inverter chargers, in turn, keep the batteries topped off and output power here to this outlet, which is your secondary power feeding the room. So the grid is connected, but it's not directly running. The grid is just serving to keep the batteries topped off. So if we disconnect the grid here at the line generator switch, there's also a physical disconnect here, like is used on HVAC systems. You'll see when I turn off this switch from line to off, the grid icon, power line there, will disappear and the controllers will beep to let you know, hey, we lost grid power. There you go. So he's off, there's no incoming power. This is just a secondary disconnect, so you can visibly know with no uncertainty that, yeah, it's completely disconnected and isolated. So right now, everything in the room, the air conditioner, the refrigerator, the freezer, dehumidifier, the lights, the TV, everything is running off of nothing but the batteries controlled by the inverters going out to the panel. And that is really the extent of it. You can hear them. They got a little louder when I turned off incoming power. Let me go over here and I'll show you. Again, this is running the odd number breakers. This is running the even number breakers to give you the opposite side of the sine wave. It's putting out 119, 120 volts, even though there's nothing coming in. To see what, there you go, input 0 volts. Batteries are at 53 volts, a nominal 48 volt system. That means they're totally topped off. It's got a load of 630-ish watts on this side, on that phase. This one has a load of 520 watts. So 1160-ish watts total is all that's going on right now in the entire room. The lights are all LED. The air conditioner is running. I can hear it running, so it's just pretty efficient. So that is really the extent of it. And this will, as it sits, it will run the room for 20 plus hours. Again, I've not run it any longer than 19 and a half, but it wasn't dead at that point. So if push came to shove, we could actually turn off some things, unplug the chest freezer, turn off the HVAC, that kind of thing, and milk it even further. And if grid power had not come back in that time, we go back to this that I mentioned earlier. That's power in from the generator. You would plug him in there, lock him in, turn it to generator power, and use power from the generator going up into there to give outside power to the inverters, which would then recharge the batteries in somewhere between 4.5 and 6 hours. I've never had to do it from fully dead, but my calculations are 4.5 to 6 hours, probably around 5. And that is the extent of it. This little guy right here, that's just a emergency light, so if you lose power, the light comes on, gives you a little light to work, to turn things on if you do happen to have him disconnected when the power goes out. Up on the ceiling, a motion activated light in case that guy is dead. Say if you lose power when you're gone, you come back late in the day and that thing has reached the end of its battery life. When you walk in here, you'll still get walk in here, that light will come on and you can make your connections as need be. Hope that rambling description makes sense. The wiring doesn't look pretty, but the reason for the red, that's just red electrical tape on these two guys. That's the positive side of the batteries coming on the red and the black. This looks like a kludge right here, but that is actually a factory cable that came with the inverters. It's an RS-485 communication bus, so they can talk to each other and let each other know, does it need to share the load differently, or what can they do? They can actually rebalance the load to a degree. They're limited by the outputs on the sub panel, but it's a pretty handy system if you're capable of doing the electrical work yourself. If not, you'll have to hire it out. That's for each person to decide for themselves. And I always keep safety glasses over here when you're messing with this stuff. You really ought to be wearing safety glasses, and everybody has 3-inch wide electrical tape, right? That's a handy thing if you've got to do a bunch of wrapping instead of doing 20 wraps with the 3/4 inch wide tape. So there we go. Got grid power on that orange cable coming in, feeding everything. Line power is feeding the inverters. The inverters are charging and taking power from the batteries as needed. And they in turn feed out to here, which feeds the secondary input to the sub panel, which feeds the whole room. Nothing to it, huh? On the batteries themselves, part of the reason for that 3-inch wide tape sitting there, for covering up the battery terminals so something doesn't get inadvertently dropped on bare metal. Just take 3-inch wide electrical tape just as an extra layer of protection for the terminals. That's the main reason for the solid top on the metal shelving, just to keep things from dropping down on the batteries, because sparks are not your friend.